So first, I have to calculate the angular speed. The linear speed is always calculated as r times omega. Formula for moment of inertia is given. It is basically sphere, circle, lamina. Angular acceleration is negative. What does that mean? It means hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, PU Mysuru. In my previous session, I have solved numericals related to system of particles. I expect that you have practiced those problems, gone through it. If you have done so, then today's problems will be much easier to understand. The first one. A body rotates along a circle of radius 0.2 meter. So there is a body which is rotating along a circle of radius 0.2 meter with a speed of 240 rotations per minute. So first, I will calculate the angular speed, or what is also called angular velocity. So there is a body which is rotating along a circle of radius 0.2 meter. The speed of rotations, 240 rotations per minute. So first, I have to calculate the angular speed. So here, if you analyze, the frequency is given 240 rotations per minute al kottidare. It is per minute. So I need to convert that to per second. Divided by 60, which is 4. So omega is 2 pi f. So this is 8 pi radian per second. See, very simple. So angular speed, angular velocity is 2 pi f. F is 4. So 8 pi radians per second. Second, linear speed. The second part of the problem is to calculate the linear speed. So where we know linear speed V is r times omega. The linear speed is always calculated as r times omega. R is 0.2 meter radius. So this is 0.2 into 8 pi. So 1.6 pi meter per second. Now, if the speed of rotation changes to 330 rotations per minute in 10 seconds, 330 rotations per minute in 10 seconds, calculate the angular acceleration, which means now F2 is given, which is 330 by 60, nearly I say 5. So omega 2 is 2 pi F2. So omega 2 is 10 pi. I have omega 1, omega 2 time. How will I calculate angular acceleration? Very good. So alpha is omega 2 minus omega 1 by t. So 10 pi. So this is 2 pi by 10. So radian per second square. So this is the value of alpha, which is angular acceleration. The second one, exactly, I have done this in the previous session. So this is a practice problem for you all. Please take out your pen, pencils, work out the problem. Now, it is a beautiful problem here. A flywheel of mass 100 kg. One wheel is there. He is calling it to be flywheel. Flywheel of mass 100 kg and radius 0.8 meter makes 120 revolutions per minute. Now, there is a flywheel of mass 100 kg, radius of the wheel 0.8 meter, and it makes 120 revolutions per minute. Again, the same way, every problem, the same data is given, same calculations has to be done. First, again, angular velocity. So, A, now again, F is 120 divided by 60, which is 2. Omega is 2 pi F, 2 pi into 2, which is 4 pi radian per second square. Now, interesting students, now you are asked to calculate moment of inertia about the axis of rotation. If you go to your NCERT textbook, there is a table given where for different objects, depending upon their geometry, depending upon the axis of rotation, the formula for moment of inertia is given. It is basically sphere, circle, lamina. You should know that by heart. This is a flywheel, a circle for which moment of inertia is m r square by 2. This formula has to be remembered. This is mr square by 2. So I is 100 into, so radius is 0.8 meters. So this is 0.8 square by 2. So when you simplify here, moment of inertia turns out to be 32 kg meter square. So as I told, if you have by hearted gone through those expressions, different objects, depending upon their geometry, depending upon the axis of rotation, we write the formula for moment of inertia, know that calculation becomes very easy. Again, the same way, the angular velocity of a flywheel decreases uniformly from 1200 revolutions to 600 revolutions per minute in 5 seconds. Calculate the angular acceleration. By now, it has to be a by heart for y'all. Very simple. So initially, 1200 revolutions per minute. So omega 1 is 2 pi f1. Without writing the formula, never simplify. I told, formula carries marks. If you directly substitute and simplify, that is not awarded. Or omega 1 is 2 pi 1200 by 60. So this is equal to 400 pi radian per second. So this goes twice, 40 pi radian per second. Omega 2. So this is 2 pi f2. 2 pi. Now this is 600 by 60, which is 20 pi radian per second. Omega 1 is known. Omega 2 is known. Time is 5 seconds. How will I calculate alpha? Good. Again, alpha is omega 2 minus omega 1 by t. Wherever you go, whichever problem from this chapter, same expression. So this is 20 pi minus 40 pi by 5 minus 20 pi by 5 minus 4 pi radian per second square. So now observe, alpha is negative. Angular acceleration is negative. What does that mean? It means that it is angular retardation. Next one, students. A uniform rod of mass 10 kg, length 2 meters, rotates at the rate of 30 rotations per minute about an axis through the center perpendicular to its length. Now, the axis is center perpendicular to its length. The speed of rotation changes per minute in 10 seconds. Calculate the torque applied. Now, all of us know torque is I times alpha. And from the given problem, very simple. Again, alpha is omega 2 minus omega 1 by t, which is the moment of inertia. In this case, it is a uniform rod perpendicular to its length. So I will be m L square by 12. So substitute, students, you get the value of I. Find out omega 1 and omega 2 as we have done earlier. You can simplify and get tau. So again, in this session, whatever may be the primary data given, manipulation is with the same expression, same formula. Know the units properly, know the relations, you can easily solve. By next class, I will turn up with few more problems on the chapter. Until then, have a nice time. Thank you.